Today we're going to solve for indefinite integral of secant cube x dx. Now to solve for this indefinite integral, first we're going to expand this expression into secant x into secant square x dx. Now why did we do it? Because we're going to use a formula of integration by parts, which states that integral of u into dv equals to u into v minus integral of v into du, where the value of u is equals to secant of x. So derivative of u is going to be secant of x into tangent of x dx, and dv is going to be secant square x into dx. So v, which is antiderivative of dv, is going to be tangent of x. Now we will plug in these values here, so we would have u into v, that is tangent of x into secant of x, minus integral of v into du, that's going to be tangent of x into du, that's secant of x into tangent of x dx. Now further simplifying it, we would have tangent of x into secant of x minus integral of tangent square x into secant x dx. Here we are going to use a trigonometric identity which states that 1 plus tan square x equals to secant square x. So tan square x is going to be secant square x minus 1. We would plug in this value in here, so we would have tangent of x into secant of x minus integral of secant square x minus 1 into secant x dx. We would further multiply this, so we would have tangent of x into secant of x minus integral of secant cube x dx, and since this minus is going to be multiplied by this minus, so we would have plus, that's going to be integral of secant x into dx. Now here we do not have to worry about this term because that's going to be added on the RHS side, because we have the similar term on the RHS, which is integral of secant cube x dx. So adding it on the LHS side, so we would have it 2 times of integral of secant cube x dx. So that's going to be tangent of x into secant x plus integral of secant x dx. Now we would divide by 2 on both sides, so we would have integral of secant cube x dx equals to half of tangent of x into secant of x plus integral of integral of secant x dx. Here now we have to just solve this term and we would have our answer. So we're going to solve this separately. So we have the expression as secant of x dx. Now here we would multiply secant of x in both numerator and denominator by secant of x secant of x plus tangent of x. So we would have secant of x multiplied by secant of x plus tangent of x and divided by secant of x plus tangent of x dx. And so further multiplying it inside, we would have secant square x plus secant of x into tangent of x divided by secant of x plus tangent of x dx. Now why did we do it? Because we're going to use a method of u substitution where we would assume the value of u equals to secant of x plus tangent of x. So derivative of u is going to be secant of x into tan x plus secant square x into dx, because the derivative of u is secant x into tan x, and derivative of tangent of x is secant square x. So we would plug in these values. So this expression is gonna be integral of du divided by u. So that's equals to ln modulus of u plus c, where c is a constant of integration. So that would be, by plugging in the value of u, we would have ln modulus of secant of x plus tangent of x plus c. Now we would plug in this value in here, so we would have half of tangent of x into secant of x plus ln modulus of secant of x plus tangent of x plus c. So that's going to be our final answer.